Welcome to this explainer. I'm your host, your trusty animated Erlenmeyer Flask, and I am literally bubbling over with excitement to dive into Year 8 MYP chemistry with you. We're going to break down the amazing properties of matter and then use that exact knowledge to totally crush your MYP lab reports. Let's get into it. All right, here's our game plan. 1. Properties of matter defined. 2. The ABCs of states. 3. Acing MYP command terms. And 4. Designing the perfect experiment. Let's roll. Section 1. Properties of matter defined. The foundation. You know, before we start any heavy lifting, we've got to make sure our chemical vocabulary is perfectly mixed and ready to react. So, I'll just quickly bubble through these crucial definitions for you. First up, corrosion. This is basically when materials just get eaten away and eroded.
Corrosion will be the metal drop in the strong acid, and then you will see the bubbles, that hydrogen gas.
Next is combustion. And the really wild thing here, without oxygen, burning simply cannot happen at all. It's this super vigorous chemical reaction. Actually, if you've ever seen magnesium sparkling with that brilliant white light in fireworks, yep, you guessed it, that's combustion in action. Moving right along, let's talk about reactivity. This basically tells us how eager, how desperate elements are to form new bonds and create entirely new molecules. Like, okay, normal oxygen gas is reactive, right? But if you cool it way down into a liquid, it becomes so incredibly reactive that objects soaked in it will literally burn explosively. No way, right? And this brilliantly illustrates how we actually use the periodic table to predict all that reactivity. Just by looking at an element like copper, right here at atomic number 29, scientists can peek at its atomic structure and predict exactly how it's going to behave and interact with other elements across the different groups. It's like a giant puzzle. Now, you'll definitely want to keep your safety glasses on for this next one. Toxicity. This refers to just how much a substance can harm living organisms. Some chemicals, like lead nitrate for example, are highly toxic to aquatic life. So we're talking special handling in fume cupboards and absolutely strict safe disposal. Our next property is radioactivity. Now this one is fascinating because it involves the actual transformation of atomic matter itself. So during radioactive decay, an unstable nucleus essentially loses energy by emitting radiation. It fundamentally changes its state and releases a ton of energy in the process. Next, let's check out oxidative properties. Honestly, this is happening all around us all the time. It's the property of a substance reacting directly with oxygen. A perfect real-world example? Think of that slow, reddish-brown rust forming on an old iron ship, or maybe a bike you accidentally left out in the rain. That is literally iron oxidizing. And finally, flammability. This is an absolutely crucial property that tells us how easily our reactants might just catch fire in the lab. Knowing the flammability of your substances, that is step number 1 in designing a safe, effective scientific investigation. Safety first. All right, section 2, the ABCs of states, which to memory. Let's look at an awesome memory trick for this. So the key takeaway here is memorizing the ABCs. Add heat, bonds break, crazy movement. It's such a simple mnemonic, but it instantly helps you visualize how particles behave when shifting from a solid all the way to a gas. Oh, and don't forget C can also stand for condensation, which essentially puts the cloud back in a cup, transitioning matter from a gas right back into a liquid. Okay, I want us to try the which to memory techniques together right now. Seriously, close your eyes for a sec and anchor the abstract concept of temperature to a real physical thermometer gun. Got it? Now anchor the concept of time to a real stopwatch. Tying these abstract variables to exact real-world lab instruments makes retrieving the information during a high-pressure test incredibly easy. It's a total game changer. Moving into section 3, acing MYP command terms. Now that we're fluent in the vocab, let's decode those tricky test questions. The absolute biggest mistake I see students making is overwriting or underwriting just because they misread the command term. Look at the difference here. If the test says state, keep it super short. We're talking one word or a short phrase. Literally no explanation needed. But if the command term is explain, you absolutely must use the word because. You got to give the underlying mechanisms and those scientific causes. Finally, section 4, designing the perfect experiment. Let's put it all together for criteria B and C. So, let's start with the hypothesis. A weak hypothesis? Well, it's really just a simple guess predicting what might happen. But if you want to snag that level 7 or 8 score, you need a strong hypothesis that scientifically justifies exactly why an outcome is going to happen.
Instead of just guessing, say, a rod will get hot, you need to explain the actual mechanism of thermal radiation and conduction. Make sense?
Now this table right here, this is your ultimate cheat sheet for strand 3 of your lab report. Just look at how incredibly specific you need to be. For the independent variable, you've got to list exactly 5 manipulations, like 5, 10, 15, 20, and 25 centimeters. For the dependent variable, name the exact equipment and units, like degrees Celsius with that thermometer gun we memorized earlier. And for sure, you need at least 5 controlled variables with exact values just to ensure it's a completely fair test. And for strand 4, when writing your step-by-step method, I want you to channel your inner bossy scientist. Seriously, use clear imperative verbs like measure, place, or ignite. Completely drop those personal pronouns like I or you. You want to explicitly state how you're going to manipulate the independent variable, exactly how you'll measure the dependent variable, and always, always include at least 5 trials to make sure your data is highly reliable. Well, as your trusty Erlenmeyer Flask, I've got one final challenge for you before we wrap up. Chemistry isn't just stuck in a textbook. Take a look around you right now. Where can you spot corrosion, oxidation, or phase changes happening in your everyday environment? Take these criteria out of the lab, stay curious, and observe the incredible chemistry happening all around us every single day. Thanks so much for joining me on this explainer. And hey, best of luck on those MYP lab reports. You've got this.